Now, in our lesson today, we're looking at trigonometry, trig application. So last week, we were able to look at our sine rule, our cosine rule, and our area rule. And before I jump into my assignment for today, if I were to just use 5 minutes, I'm not going to do the whole thing again, but I'm just going to let you know what is it that I should know when it comes to my trig application. So a quick summary would be very, very important. Summary. So last week's lesson is available. You can always rewatch the whole content. First, please, we must be able to prove sine and cosine rule. You must know the proof. The proofs are examinable. The examiners are going to ask you to prove sine rule and ask you to prove cosine rule. Okay, so the proof is very, very important. Plus the application. All right, so prove sine and cosine rule. Number 2, we then said that there are 2 types of triangles. All right. We said there is a right angle triangle, which you usually call a RAT. Every time we see a right angle triangle, we usually do 2 things. Number 1, we apply the rule of what? Pythagoras, and we apply so, ka, so. This we learned from grade 10, so we're not going to waste time on that. But it is important to apply that. Okay, right angle triangle. We apply just 2 things. Now, non-right angle triangles. Non-right angle triangles. First thing that I quickly want to go through here, although I should have gone through it when I was saying right angle, but it's okay, is to quickly help you see angle A, angle B, and angle C. The side facing angle A, we usually use a small letter A. The side facing angle B, we usually use a small letter B. And the side facing angle C, we usually use a small letter C. So if I say PQR, it will apply again. Capital P and small letter P. Capital Q and small letter Q. Okay. So this triangle is a non-right angle triangle. And when we see that, we can no longer apply Pythagoras. Neither can we apply what? SOHCAHTOA. This is where we now apply our sine rule. And what is our sine rule? A over sine A equals to what? B over sine B, C. And some of you may be wondering, but my teacher said sine A over A. It is practically the same thing. I can flip it over and sine A over A, sine B over B, and sine C over C. I'm going to come back to that sine rule, and I want to show you something. Then we move to cosine rule. I know the formula looks weird, but we're going to get used to it. A squared will be equal to, I'm going to deal with the other 2 sides. Other 2 sides will be what? B squared plus, now what do you notice? That's about Pythagoras, if you look at that, almost. Minus 2BC, now that's the standard formula, cos A. And here's what I quickly want to point out. I'm not going to worry so much about when to use sine rule. Please listen to me. I am going to worry about when to use cosine rule. And if cosine rule is not applicable, then I'll use sine rule. And how do I deal with my cosine rule? I am going to split this formula into 2. If you notice, all right, we see something that looks like Pythagoras, but small a, small b, small c. are all sides. So every time I see that I have 3 sides, I can use cosine rule. So that's easier to remember because it's on the formula already. When I am given 3 sides, so I look at the triangle, I can then quickly bring in cosine rule. We are going to do some work tonight. Now look at the second part of this. Look at the second part. Interesting. Check this. I have a small letter b, I have a small letter c, and I have a cos A. I'm going to highlight those letters for you. I have a small letter b, I have a small letter c, and I have an angle. Oh, look at the position of that. What do you notice? Side, side, and this angle is included. So when do I use this? When I have side, angle, side. So I'm talking about 2 sides plus an included angle. If these 2 conditions are not in, don't waste your time. Sine rule works. But for the sake of learning, I would use sine rule when I have 2 sides plus an opposite angle, or 2 angles plus 1 opposite side. Always remember, every time we say sine, it's opposite. So anything that is attached to opposite of an angle, sine quickly plays a good role. All right. So that's my cosine rule there. Finally is the area rule. All right, we know that area could be half base times height. That is only if I am given a base and a perpendicular height. Always know that the base and the height are perpendicular. That's very important. But otherwise, area can be written as what? Half AB sine of what? C. And again, if you quickly investigate on the letters small a, small b, and c, small a, small b, and angle in between them. This, we're going to take this back to Euclidean geometry very soon. All right. So what do you notice here as well? When do I use this? When I have what? Side, angle, side. 2 sides plus an included angle. And finally, hint, to make it easy, always split your triangles, your shape, into 2Ds. If you carry these 2 through to grade 12, it's the same. If I was teaching a grade 12 class, I would do the same thing. And that's my summary. For those of you that have done it, this would make sense. For those of you that haven't done this topic, just hang in there. Look at how we are going to crop each formula and apply it. And that's my summary. That's the end of the topic. We did the whole of this. We actually did the proving. We proved all of this last week. Please get back to, I know your school as well, teachers would be doing the proof, or get back to last week's lesson and just learn the proof. The proofs are examinable. All right. Are we okay, everybody? I want to now jump into questions. We have 1 hour. The proof. No. It's just sine and cosine rule that we need to prove. But we must apply all the 3. Guys, are we okay? We're going to cascade our activities from easy to easy and then to easy, because it's not difficult. Can I move? Let me know. Give me a thumbs up if we can move. I will do the first one with you and allow you to try the second one, and we just proceed like that. So my first one would be to show you what to do, how to do it. Guys, the problem I have with learners, with you all, is this. We show you something. When we give you what to do, you want to do your own way, and it drives me nuts. Like, completely drives me nuts. So and that's why you say, oh, but sir, when we are doing it in class with you, it's easy. Yes, because we follow a method. But you want to be clever. And you do your own things. Here's our first one. Oh, I wanted to mention something, guys. Whenever you hear the word vertical, there's a 90 degrees. Please take note of the word vertical. That's very, very important. I wanted to add it somewhere. I hope you remember. Just put a star. Let's put a cloud. Vertical connotes perpendicular lines. Take note of that. So every time I see the word vertical, I know that there's a 90 degrees. All right, so vertical connotes perpendicular lines. That's very, very important. Sometimes they won't tell you it's 90, but they'll tell you the word vertical. Okay. All right, let's look at this question quickly. 5 marks, not so difficult. In the diagram below, AB is a vertical pole. Did you see that? Already there's a 90 degrees there. And this examiner is kind by showing us that. The angle of elevation from C to the top of the pole is alpha. You see, don't read as if you're reading English. Pause, look at the diagram. That's my alpha. And the angle of elevation from M to the top of the pole is theta. CM is X meters. All right. Now, if I were to ask you, how many triangles do you see here?
3.
Okay. Can I get responses from those of you at home? That's how it's going to be easy. I promise you. How many triangles? Do you want to respond quickly for me? Do you see? All right. Thank you. If you want this thing to be easy, Tariq, do you need glasses, my boy? How do you see 2? All right, you corrected it. It's 3. And the 3 do have information. Now, what are the 3 that I see? Maybe it's different from the ones you see. I see a small right angle triangle. I see a big right angle triangle. And then I see an obtuse triangle somewhere there. Okay, so I'm going to label them. So draw out all, that's what I meant. Draw out all the, it's going to be a lot easy for you. All right, show me that that's 90. Show me that's 90. Let's label A, B, M. And that's theta. I don't know if that's the triangle you guys are referring to. A, B, C. And that's alpha. I'm going to call this for emphasis, triangle 1, triangle 2, C, M, A, X. What is this? Alpha. Can I say this is 180 minus theta? I'm just filling in information quickly. Please let me know where you are lost, especially when I said 180 minus theta. If there's a question, quickly raise an alarm. Please give me a thumbs up if you are okay with my 3 triangles. Yes, talk to me there, Kilebohile. Unmute yourself. I see your hand, Kilebohile. What's the question that you may have? Kilebohile, talk to me. Your hand is raised. Otherwise, I'll guess the question. I think the question might be, how did I get 180 minus theta? Probably that's the question. Angles on a straight line. All right, I don't know if I need it. I just wrote it. Show that the height of the pole. Now, this is where we start talking. Show that the height of the pole is given as AB. So I'm looking for AB. Now let's look at all the things they combined. They combined X, they combined sine alpha, They combined sine theta, and then they said sine alpha theta minus. I wonder where that angle would be. But we're going to find out. So we're looking for AB. We have 3 triangles. Okay, look, I see that there's a sine alpha in this thing. Can I look? I see sine alpha, I see sine theta. Can we find those two? Because both of them are kind of connected to what? AB. So if I consider, I haven't done this before, we're going to check. If I consider triangle 1, what is AB? Okay, let's see something here. What else do we know? We need something common. We need something common. I have AB because I don't know if I'm going to use that. All right. And I don't know if I'm going to use that. So it's kind of tricky, but we'll get there. All right. Let's see something here. For triangle 1 and triangle 2, those are right angle triangles. Okay, so here's my cue. I'm looking at what I'm given. Can we find sine alpha? What is sine? Sine of an angle is opposite over what? Hypotenuse. So can we work with that? So sine alpha will be what? AB over what? AC. Because that is opposite and that is... All right, let's start from there. Let's write that down. We don't know where we're going because this... So sine alpha is, what did we say? Opposite AB over AC. Lovely. Okay. And if I were to cross multiply, what do you notice? AB would be what? AC. Okay. I'm having an idea now. Do you notice in the answer, we do not need to have AC? Look at, keep where we're going at the back of your mind. We don't need AC. Can we get AC? I want us to quickly get rid of AC quickly. For me to get rid of AC, I think I will come to triangle 3. Because that's where I have AC. What do I know about triangle 3? Let's observe quickly. In triangle 3, okay, I'm looking for this. I have that. So what do you see? Side, angle, and side. So I have 2 sides and an included what? Angle. I'm going to draw that out here so that I can take you through again. So check this. Remember, the aim is I don't want AC because AC is not part of what I'm looking for. So I quickly want to remove it. It's A, C, and M. This is given as X, and this is given as, what's the angle there? Alpha. All right. So that if I get rid of AC, I can substitute it there. All right. So now let's make this easy. I'm going to use small letters. Now, if I'm looking for this and that and an angle between, are we going to be able to use sine rule or cosine rule? Cosine. Should we use cosine rule? Because I want to check something. Keeping an eye on where I'm going. AM and that, X and that. That will be what? Sine alpha. Is it sine alpha or theta? Sine alpha. Okay, I just want to play around a few things. Or rather, before we start, can we find sine theta? I want to check something. What is sine theta going to be? Opposite over what? Okay, let's put that down as well. Sine theta. So we can do all the conjunctions. Sine theta, opposite over what? Oh. So, AM. Can you see where AM is? That's where AM is. Beautiful. Beautiful. All right, so if I need to get rid of that whole stuff there. I need to get rid of that whole thing. Okay. It's either we find AM, we need to find AM and we need to find AC, both of them. Look, if I were to try, what did we get for this angle again? 180 minus theta, right? What do you think angle A would be? Let's do maths. Sum of angles in a triangle. Okay, so angle A, just want to see something quickly. Angle C plus angle M should be equal to what? 180. What is angle A? We don't know. Plus alpha plus 180 minus theta should be equal to what? All right, what is angle A? If I move this 180 over, it's going to cancel. If I move this theta over, what would it be? Positive. And if I move that over, what do I get? Wait, do you notice theta minus alpha? Is it part of the question? Look at the denominator.
Yes.
So you got to be clever here. Theta. All right. Now, let's be clever. Let's be clever. We see sine, right? So let's work with. This is very lovely. I love this. Let's work with sine rule because the examiner has sine. All right. My good learners, if I come here, that would work. This and this would work. I'll repeat. I have my angle. See, I have all the three angles so I can play around. That, I have the opposite side. This angle, I'm looking for the opposite side. So, can we therefore say, if I start with AM as the side, what's the angle opposite? Sine alpha. Is that fine? And then this angle and the side. X over sine theta. I hope I haven't lost anybody because we don't know where we're going. This examiner is playing tricks. We also have to be smart about it. Again, I'll repeat. Side and angle. Is that fine? Side and angle. If you notice, I think I have everything I need. It's now a matter of bringing everything together. But I still have that AC which is going to disturb me. But anyway, my good learners, let's do some maths. Let's play around. Let's play around. If we cross multiply here, what is AM? All right, I'm going to be very slow here. Sine theta minus alpha. X sine what? Alpha. Just by cross multiplying. What is AM therefore? X sine alpha over what? This is really looking like. Wait, what were we supposed to get? Let me write it here. We're supposed to get AB equals to what? X sine alpha sine theta over. If I'm right, let me just check again. Sine alpha sine theta. All right, I think we're close. We're very close. We are very close. I don't know if you notice that the arrangement is coming together. How do we bring that in? Okay. From here, but we know that AB, this examiner just played around. I think they played with us. AB, if we cross multiply, is AM multiplied by what? By cross multiplying. They played with us. They dribbled us by taking us to AC. We didn't need AC at all. I don't know if you can see your answer. We didn't need AC at all. There's nothing that concerns AC. So sine theta is AB over AM. And if I cross multiply, AB is what? AM sine. But don't I know AM? I think I do. What is AM? X sine alpha over sine what? Theta minus alpha, multiplied now by what? Five marks. Beautiful. Oh, I thought we were starting on something very easy, but we had to be dribbled round and round and round and round. So when they ask you to prove, don't take your eyes off the answer. Keep your eyes on it. It's okay. What is it that I can get? What can I get? Pull everything together. First question is done. Is there any question, anybody I lost, you want me to bring you back quickly? I'll be willing to do so. Just by a show of hand, a type in, unmute yourself quickly. We have just 2 minutes to go through if there's anything here that you may need. Please give me a thumbs up if you are okay with it.
How did we get the momentum again?
How did we get?
The A divided by sine alpha equals to X sine alpha minus theta minus alpha.
Sine rule. We applied sine rule. AM, the side, that's the opposite angle, sine alpha. The side, and that's the opposite angle. So what helped me was to keep an eye on, I need theta minus alpha. I need sine alpha. So I need all of those things. So sine rule brought it all out for me. So always fill your information and walk through. All right, I don't think anybody has a question. I got all thumbs up, and somebody, Kile Bokile said I'm okay. All right. Let me see this. Can I give you 5 minutes to try this one? Or you want us to walk through this? Okay, let's walk through this together. In the figure below, ABC is a triangle where AB is perpendicular to BC. ACB is angle P. And CB, guys, very important information they've given us. CB is 3AB. Triangle DCB is drawn so that DCB is 30, angle DCB is 135, and all right. The first thing that I love to do all the time, please, don't tell me that you are now an expert. Draw out those triangles. It will assist you. I've seen learners that say, and then they struggle. But for me, I just draw out. It doesn't take, I don't know how many seconds to draw these triangles. But drawing those triangles have saved me so many times. A, B, even in this last question we did, you notice it saved me as well. But somebody says, I'm not drawing, I can see. No problem. All right. We were told that CB is 3AB. CB is 3AB. Triangle 1 and triangle 2. Determine the value of P. Correct to how many decimal places? 3. Okay, so let's go inspect our triangles. Where do we have more information? Is it triangle 1 or triangle 2? What? Triangle? Remember what am I looking for? I'm looking for P. You're saying triangle 2. Okay, let's quickly observe triangle 2. What do I have? I have an angle, I have a side, No, it's not going to work. Do you know why? Even if I want to try sine rule, that and that, and I cannot use cosine rule. I don't have 3 sides, and I don't have 2 sides and an included angle. Why don't we go back to triangle 1? What's triangle 1? It's a right angle. When we see a right angle triangle, what do we use? SOHCAHTOA. Now check. Look at what's giving it away. This is 3AB. And this is AB. What do you notice? I have opposite and adjacent. So number 1, tan P. I hope you understand why I'm using tan. Opposite and look at what happens to your AB. They cancel each other. Does that make sense to you guys? And I can find P therefore. Hi Sam. Guys, ask me questions please. The more you do these things, the better you see. Can we throw that in a calculator to get an answer? The arctan of 1/3, 18,435. They said 3 decimal places, 18,435 degrees. Oh, look at 7.2. If P is 18,4, determine the value of CD. Now, please, my dear learners, the examiner is saying the value of CD. I have no business in triangle 1. No business at all. Yes, talk to me. There's a hand. Is that a hand there? All right. I have, yes, is that a hand? Iyad? Oh, okay. I have no business at all in triangle number what? 1. So let's focus on triangle 2. What are we looking for? Okay. I'm going to highlight. What is it that we know? Sorry? We can now use B because we know the value of P. Okay, wait. That, I'm looking for that. Oh, this and opposite. You see, I have 2 pairs of opposite things. Side, opposite angle. I'm looking for side, opposite angle. What is it? Sine rule. We're done. All right, number 2. So we say, I'm going to write the whole thing. dB over sine C, so that we can follow, equals to what? CD. And what's the angle opposite there? Sine B. So it's the side and the opposite angle. Emphasis again, look at it. It is the side and the angle opposite. It is the side and the angle opposite. Guys, here it's just METS now. Not it's METS lit. What is dB? 121. Sine what? 135. What is CD? That's what we're looking for. What is sine B?
P over 2, which is 18.435.
18.4. They said we should use 18.4, right? Can you do the math for me and get me CD? Do the math for me and get me CD. Share answers with me, please. 27,36. That's the answer I'm getting from you guys. I think I have 3-4 people already giving me that answer. And there's somebody right in this class who's not sure of what to do. We just, look, the whole idea, I want us to do math very simply. You are looking for CD. Just move this whole thing here, because that's what you should be getting rid of. So what should I have? 121 multiplied by what? Sine 184, and everything divided by sine 135. Calculator quickly. 121 sine what? What am I doing? 18.4 over 2. We close the bracket. Sine 135. 27,36. And that's the answer you guys gave me. Well done. 27,36 meters.
Yeah, I got 27,37.
37. Okay. Maybe you rounded off early. Guys, are we okay? Make sense? We're done with that whole question. 5 marks in the bag. Can we move? Okay, do you want to give this an attempt? Try. This is your first self-attempt. Don't be afraid. Try. I'm giving you 10 minutes to try. It's enough time to try. Enough time to try. How far did we go, guys? Were you able to get any answer? Thumbs up, thumbs down. It's a first trial, don't worry. Oh, some people are done. Lovely. See, Bodola said done. Okay, let's try. Let's try, don't worry. In case you were not able to win through, don't worry. Don't beat yourself too much. We'll do it together. And the diagram, VP is equal to PQ. Where's VP? All right, VP is equal to PQ. You know what I will do instantly? I'll transfer that information there. 5. RQP is equal to SPV. That's alpha alpha. Okay, that has been given. SPR is equal to beta. Lovely. And PQ is parallel. Okay, look. Bring in Euclidean geometry instantly, right? Fun angles there. SV is perpendicular to VP. SV perpendicular to VP. All right. Instantly, what did I tell you to do? Don't be lazy. How many triangles can you see here? I see 3. Don't be lazy to say, but they didn't ask me to do that. Maybe some of you did not. And you struggled. That's what I know in the first triangle. Then I see another triangle somewhere there. And that triangle is SRP, and that is beta. And then I see a third triangle which looks like that. And that is R, Q, and P. I know this as 5. I know this as alpha. Now, quickly, let's look at those parallel lines. I like to analyze before I even start. If I have parallel lines, check here. Oh, alternate angles. You see, by quick observation, do we agree that they're alternate? All right, so R is equal to, maybe that will help us along the way. I'm not sure. Okay. What else can we see from those parallel lines? We're looking at co-interior. Okay, that's going to be too hectic because I can bring in. Okay, let's leave it like this for now. If we need anything, we will come back to it. Lovely. Express PS in terms of alpha. Oh, where's my alpha? I forgot this. Now, guys, when they say PS, I'm going to look for a triangle that has PS and alpha. PS. I don't have any business in triangle 2. Neither do I have a business in triangle. See, can you see that I've reduced my work? So I'm working with this triangle. And this triangle is a right angle what? What do I use? SOHCAHTOA and Pythagoras. What am I looking for? I'm looking for PS, and that's my hypotenuse. With reference to this angle, this becomes my, oh, lovely. So adjacent and hypotenuse. So number 1, cos alpha is adjacent over what? So what is PS? 5 over cos alpha. We are done. It's 1 mark. Number 2. Determine RP in terms of alpha. Now, guys, quick one that I should tell you that I forgot. Every time you do something, go and write it there. What did we get now? We got PS, right? Where again do I have PS? So that I can see what I have. Determine RP in terms of what? Alpha and beta. Where's RP? Okay, RP. There's also RP here. In terms of what? Alpha. Do we have alpha here? Do we have beta here? Okay. All right, do you notice we have alpha and beta here as well? So we've got to, but let's see. What are we looking for? RP. Oh, check. I'm looking for that side. I have an angle. Ah, we are done. I have an angle and I have an opposite side. I don't know if it makes sense. RP is the side, but I have the angle, opposite angle, sine alpha. Then I have PQ, which is 5, and I have the opposite angle. What am I looking for? RP. Just move the sine alpha. So what do we have? 5 sine alpha over 3 marks in the bag. I don't know if we are on the same page, everybody. But is it making sense? Split, analyze. Okay. You forgot to read. That's the first thing. All right. Hence, show that the area of triangle RPS. Now let's go inspect triangle RPS. Do we know RPS? Where's RPS? RPS. Oh, the area of this triangle is giving us that. Ooh, that's going to be interesting. Oh, but we know RP. Do you notice we know RP? All right, we know that. Okay, it's too long. Wait, area. When do we use area? Side, angle, side. Do we have it? Side, angle, side. Yes, talk to me. There's a question there, Sam? 7.2. Okay, I'll do it again. All right, Kile, I think I also see a message. Explain RP. So the first thing is to observe. I'm looking for RP in terms of alpha and beta. My job is to find the triangle where RP is. And I see there's RP here. Oh, and they said alpha and beta. Alpha and beta. So this is a good triangle. Because I also have RP here and I have alpha and beta. It's kind of complex for me. So observing this triangle, it's either sine rule or cosine rule. Quick observation. I'm looking for the side, but I check I have the opposite angle. And that is what sine rule requires. Then I have the side and I have the opposite angle. I don't know if that makes sense. It's a pair. Side and opposite angle. Side and opposite angle. Does that make sense to you now? That's what we're looking for. Side. If you remember what I told you, I said we can use sine rule when you have what? 2 angles and 1 opposite side. So I'm looking for this side over that. So RP over sine alpha. Then the side again, 5 over sine beta. And then I cross multiply by moving this here. Are we on the same page now? Okay, Kile, are you okay? Sam, we're good as well? All right, thanks, Kutluano. All right, beautiful. Okay, so we go back to the area rule. To use area rule, it has to be side, the angle, and the side. Okay, so let's see. I don't know if we're going to get it. I'm seeing some funny tan somewhere there, but we'll see. Number 3, area of RPS. Will be half. It's the 2 sides and the angle between. The 2 sides and the angle in between. I don't know, but let's see. It's the 2 sides and the angle in between. Okay, so half SP PR cos, no, sine. Sine what? Sine P. Don't forget the 2 sides and the angle. I want to repeat. Area rule. half the two sides. So it's side, angle, and side. So SP, PR, and sine P. Okay, let's substitute together and do the maths. What is SP? Do we know SP?
Yes.
5 over what? Cos alpha. What is PR? We got it. 5 sine alpha over sine beta. And our P is beta, right? What is 5 times 5? On top. 25. Guys, sine beta would cancel sine beta. Do we agree? But what is sine alpha over cos alpha? Let me write it out for you. And your 2 is there. Do you notice that's 10? They wanted, I was thinking in my head, where will I get 10 from? Done. Case closed. We are done. Case closed.
How come you sine and sine cancel?
Huh?
Sine beta.
Sine beta over sine beta is 1. Make sense? It's like 5 over 5. Let me know, guys.
Okay, right. Thinking, yeah.
Huh? Lots of thinking. All right, can I move to the next one? Eight marks. Would you like to try? That would be the ideal thing. 10 minutes again. 10 minutes, walk through. Split it, analyze it, you'd get it right. Did we manage, guys? Talk to me. Give me a thumbs up. All right, I'm seeing thumbs up there. Lovely. Second one. Beautiful. Guys, if you are not winning, give me a thumbs down. I need to see a response from you all. See, it helps me to see. All right, thank you. Beautiful. I see 2 thumbs down. It helps me to see where you are. No one should be neutral. It's either yes or no. If you're not satisfied, thumbs down. If you're okay, thumbs up. You're getting 1 out of 4, thumbs down. You let me know like that. Okay. I don't want us to be neutral. Matica Lady is giving me nothing. Paul is giving me nothing. Bass is giving me nothing. Samia is giving me nothing. Yeah, guys, give me those responses. I've always been crying for those responses. They matter to me. Thank you, Tariq. Yeah. That's why it's called tuition. Thumbs down is allowed. Okay. All right. No one is going to shoot you. We'll only shoot you in the exam. Okay. And there's so many processes before that exam. All right, let's look at this quickly again. In the diagram below, PQ is perpendicular, QPS is alpha, and QRP is theta, and PR is K. I'm not even going to go to 7.1. How many triangles do you see? I see 3 triangles. Okay. And in looking at those 3 triangles, I see 2 right-angle triangles. I don't know if I'm right. I see a small right-angle triangle. Okay, I got it. I see a small triangle there. And I see a bigger triangle. Okay, just for space sake. We just label it quickly. And then I see, what other triangle do I see? Non-right angle, but does it have information? Is there anything that has PS here? No. Okay, so I'm going to keep my 2 triangles for now. Let's see something. That triangle I don't see. It doesn't have what? It doesn't have PS, but do we need PS? I'm not sure. Okay, let's see quickly. So I'm working with things that have what? Info. I see theta minus. Oh yeah, we're going to need it. P. Yeah. All right. Let's look at PQR. What do you notice? That's theta, right? No, PQR, the big one. Now, on the other hand, if I were to draw the small one, PQS, that is what? Alpha. Then I have that other little triangle there that looks more like that. S, P, and R. And instantly, I should know that is what? Theta minus alpha. How did I get to that conclusion? This whole angle is theta. This small angle is alpha. So that is the remaining. Okay. PR is what? PR is K. Don't let's forget that. PR is K, PR is K. I'll call this triangle 1 for labeling sake and reference. Okay, we all should be okay with that. So if you notice, I'm doing what I ask you to do. Write down size of RPS in terms of alpha and theta. First thing is to go and check the triangle that I need. I'm looking for RPS, which is angle P. But in terms of what? Alpha and theta. R P R. We are done already. Look, it is R P S. Theta minus alpha. Question 1 is done. So it wasn't a waste of time. It wasn't a waste of time. Show that RS is equal to, okay. Show, why is that? Is only now you're saying. Show that RS. Where am I looking for? I'm looking for this. They said, look at all of this. Where would you find all of this? I already know theta minus alpha is there. I know, oh wait, I know K is here. Huh? RS is here. But hold on, why are they bringing in cos alpha? Am I missing an angle? 3 marks. Okay, let's see. Is there another RS somewhere? RS. So RS is only here, right?
Yes.
Okay, wait. Okay. Wait. If this is alpha. Okay, let's be clever here. Because this is what I'm looking at. I'm looking at one angle missing. So I want to show you my thought pattern. RS, that's a side. Over this.
Yes. K is a side.
Is that okay? This and the opposite.
Yes.
K. So I'm looking for this angle. What is this angle S?
S2.
S2. Oh. Let's do a bit of geometry. Q, Q, Q. This is an exterior angle. Is equal to sum of opposite interior angle. 90 plus. Ah. Even if you don't see that, look, you can work out this one. What is this? 90 minus alpha. Then say angles on a straight line. For somebody who is not seeing that, S1 plus S2 equals to what? 180. What is S1? 90 minus alpha. Because I already see that I need that S2 from my analysis here. So I needed to go find it. S2, if you move this over, it becomes minus. So it's 90. Can you see? We're back there. All right. I think I'm done. Can I use sine rule now?
Yes.
K over sine S equals to SR over sine P. So SR is equal to K, if I cross multiply, sine P over sine S. Now, what is sine P, by the way? What is P? Theta minus alpha over sine. Oh, wait. What do you notice? Cofunctions. Whenever we see 90, what do? We change the trig what? Ratio. Do you remember that? And it becomes cos. And it's a positive value. How do I know? I taught you how to use your calculator to check. If I say sine 90 plus 1, is that a positive or a negative? It's a positive. And because there's 90, it's a co-function. Cos alpha. Case closed. Number 3. Calculate the length of RSR. Guys, even if you didn't get 7.2, please use it in 7.3. They gave you all that story. They gave you RS. What is K? 17. Sine. What is theta? They gave us 58. So don't get stuck there. 23 over cos alpha. And alpha is, don't get stuck. Use it. We are done. We're getting there. 17 sine 58 minus 23 over cos 23. 10,59. What's the unit? Units. Are we together before we look at the last one? Show that the area of RSP, let's duplicate this page. RSP. All right? It's an area rule. Which triangle is RSP again? Where is it? RS, is equal to, okay, if we look at that triangle, area rule, we need two angles, two sides, and an included angle. By the way, we do have RS. Oh, we have K. K is 17. Let me draw that triangle. Let me draw that triangle. Do we have K? Yes. What is K? 17 units. This is S, this is P, and this is R. What do we know? P is, what is 58 minus 23? 25. 25 degrees. We know S. 90 plus 23. 113. We know SR. We got SR just now. What was SR? 10,59.
Yeah.
I need two sides and an included what? Angle. Guys, don't you see that I know this side and I know this side? Can I get this angle? Sum of angles in A. So what is angle R? 180 minus 25 minus 113. What would that be? Give me an answer. 40? All right. So area therefore will be what? Half. What are the two sides? PR, SR, sine R. Don't forget, guys, it is, let me mark it, side, angle, side. The angle must be in between. Hopefully we're going to get 48. What is PR? 17. What is SR? 10,59. Sine what? 42 degrees. Okay, heart is beating very fast. That's what happens when they say show. But we have done everything well. 0,5 times 17 times 10,59. Sine what? 42. Are you sure you're giving me 42 correct there? We're getting what? 48 square units. This is giving me 60. 58 minus 23. Oh, 58 minus 23 is 35, not 25. 35. My bad. 35. Can we change that for me? That should be 32. 32. All right. So let's retry that now. Zero comma 5 times 17 times 10,59 sine 32. 47,7. Rounded off to the nearest square unit, 48. Are we on the same page? Yes, talk to me. There's a hand.
Hey sir.
Yes, talk to me. Hi, how are you? Bonolo,
Hey sir.
talk
Can
to
I
me.
get the answers from the previous slide?
From the previous slide.
Yes.
There you go.
Thank you, sir.
Okay. Are you ready for the next question?
Can you see the answer?
Ready for the next one? We just keep trying, guys. We just keep trying. Keep trying. Don't give up. Don't give up. Next one. Your facial expression. You are already defeated by just no. Don't do that. It's 7 marks. It's 7 marks. So look already. Can I tell you that I have 2 out of 7? The last one.
Yeah.
Just I have not read, but they said determine the value of x if theta is 15, beta is 60, alpha is 30, OQ is 5 root 2. I have everything. So I already have 2 because I'm just going to substitute here to get my x. So I already have 2 out of 7. I'm not hopeless. I should fight for 5. You see? I'm not hopeless. I have a 2. So don't be defeated. There's hope.
I supposed to have 5 and 5 for 2.
No, but there's you have a good place to start.
The 5 for 5 is too much.
Okay, 9 minutes.
Yeah.
We're looking for 5 marks now. 5 marks only. Hi guys, are we winning? Are we winning?
Too many thumbs down.
Too many thumbs down. Can we mark quickly? Let's mark. Let's mark. All right, it looks difficult though. By just looking at the diagram. I think that's what killed you here, the diagram. All right, a man standing on a horizontal plane at Q observes two helicopters. Okay, let me get my highlighter. This man is standing where? Huh? A man standing at point O rather. All right, observe two helicopters positioned at P and Q. The lines of sight from O to reach each helicopter form angles of elevation beta and alpha with the horizontal plane. Additionally, a second man located in the helicopter at point P, all right, observes the helicopter at Q. In his line of sight forms an angle of elevation. All right, they're just giving us all of this. P is measured along line PQ. All right, lovely. ON is perpendicular to NR and OP is X. Beautiful. Can we split the triangle? What triangle do I see here though? I think I only see one major one, two. I see a right angle here and that. Okay. Show that OQP. Where is O? OQP is 180 minus. All right. So if you look at this triangle with me, guys, whenever we talk about angle of elevation, you see this line? They won't tell you is parallel to this. That's angle of elevation. So that, and that, automatically, this is what? Theta. And what will this angle be? It's the big angle theta. What does the examiner want? Oh, basically we want angle what? Q. Let's see. So, can I say that angle O plus angle Q plus angle P should be equal to what? 180. What is angle O there? We got what? Theta minus beta. We are looking for angle Q. What is P? Theta plus alpha. Oh, I don't know if I'm gonna, let's see something here. Is anything cancelling out here? Yeah, theta. Wait, are we supposed to have theta? Why do I have alpha? Oh, there's alpha there, right?
Yes.
There's alpha. There's alpha. Okay, let's work this out and see what we're going to get. We're looking for Q. Theta plus theta will give me what? 2 theta. That's not going to work for us. That is not going to work for us. Okay. Because that will give me 180 minus alpha plus beta minus. All right. So this is not working. Let's see what the examiner is looking at. OQP. OQP. Okay. Let's look at the triangle again. So we're looking for this. But like we said earlier, this is a horizontal line. If this angle is theta, that angle is also what? Theta. Wait. This is beta minus theta. Error. The big one is beta, right? The big one is beta. Can we quickly fix this? I think we would get an answer now. What is O? Beta minus theta plus Q. What is P? alpha plus theta equals to what? Do you notice this and this would cancel out? Yeah, so what is Q? 180 minus, this is beta plus alpha. And if I just do that, all right, we're done. So our thought pattern was correct, was just that little error. Question 1 is done. All right, Freeman, you got x as 10. Okay, we're going to check that out now. Are we okay there, everybody? Number 2, show that OQ, and that was just geometry, you know, just basic geometry there. Show that OQ is equal to, so we're looking at this triangle. We're looking for this. Instantly, look at what I see. I have that. I have this. So, if you look at this side, it is opposite this angle. If you look at this side, it is up. I think I'm done. I don't know if you see what I'm saying. OQ, what's the angle opposite OQ? That's P. And then what? OP, which is X, sine Q. We are done. What are we looking for? We're looking for OQ. OQ is OP sine of P over what? Sine of Q. Now, what is sine P? What's the value of P? Oh, what is OP, by the way? OP is X, right? Let's substitute quickly. Sine, what is P? Alpha plus theta. This is so simple, man. What is Q? We already know Q as what? Check. Sine 180 minus alpha plus beta. This is where they want to catch you. Do you guys remember how to reduce? If I ask you to reduce sine 180 minus k, what's your answer? It's sine k. That's the second quadrant. Sine is positive. So if I have sine 180 minus all of that, I don't know if you see your answer already. Therefore, OQ is X sine alpha plus theta. If I then reduce, what do I have? Sine alpha plus, we are done. Come on, people. Number 3. We need to do something with cosine rule. I don't like all of this sine rule, sine rule, sine rule. Are we on the same page? Are we okay, everybody? Come on, guys. The last one, you should be able to get X, please. Please. What do? We substitute, right? Look, I can simply say OQ. We're looking for X, right? So can I just substitute there quickly? What is OQ? OQ is 5 root 2. You get 1 mark for doing that. What is alpha? We're given alpha as 30. What is theta? 15. Already that's sine 45. What is alpha again? 30. What is beta? 60. Guys, I can even do this without a calculator. Sine 90 is 1. Sine 45 is what? Root 2 over 2. So what is x? 5 root 2 divided by root 2 over 2. X is 10. Confirm with me. X has 10. I think somebody gave me 10 there. So it's 5. Check. It is 5 root 2. If I cross multiply, I have sine 30 plus 60. And then divide by sine 30 plus 15, which is sine 45. 10. We're done. So the diagram is just there to... The diagram is there to... Wow. And it's just a toothless bulldog. All right? All of these are grade 11 papers. There's no grade 12 here. It's a toothless... And you guys are just running for something that has no tooth. It's like you're running from a lion. You know those lions that look like dolls in the house. So you've got a little tiger, a dolly tiger, and then you enter the house. That's what it does to you.
Yeah.
Do you want to try this as the last one? But let's try. Look, it's 2, 4, 2, 2. 6 minutes. What can you do? Guys, I am not going to do 5.3. Do you know why? 5.3. They want, if x is 15 and theta is 22, everything is here. So our job is 5.1 and 5.2. Quickly, 5 minutes. 5.1 and 5. All those substitution things are, come on, that's grade 8. 5 minutes, let's try. 5.1 and 5.2.
Actually, that's good. Using the...
This?
Yeah. We can get them.
Here. Here.
Yeah. How much are they?
Grade 12 is 250. This one's are what? 180 or so. I just need to check. Freeman says, is this going to be on YouTube? Yes, we would put it on YouTube. But if you want more, send us a message. Okay, let's answer quickly, guys. We're only answering the first two, right? The last one is just you substituting and then, okay, but how would we do this? First needs to read. In the diagram, PQ is a vertical. I told you about that vertical word. QRS are points on the same horizontal plane. The angle of elevation is given as 120 there. PQ is equal to, all right, what's your first step? Draw out the triangles. Make them 2D. Okay, what triangles do you see? Okay, look at this. I've got a triangle here that is labeled as, I'm going to be fast on this one, PRQ. That is X. And that is what? Theta. There's another right angle triangle. I'm not going to draw it like this. I'm going to draw something simple. It's PQS. I don't know if you can see that. We're now getting into the core of this 90 degrees. We're now getting into the core. PQX. Then we have what? Oh, we have PRS. Beautiful. So we actually have 4 triangles here. PRS. Where's PR? Something like that, right? Doesn't have to really look like that. At least I must just capture all the information. It's PRS. And this angle is about 120 plus theta. Okay. And RSQ. Okay, very important triangle there. That 120 plus theta, I'm just looking at that. We'll need to reconsider that. But for now, RS and Q. And we know this as 120. So triangle 1, triangle 2 for reference straight, triangle 3. All right, number 1. Determine QR. We're looking for QR. All right. In the form of, in terms of what? Okay, which triangle? Look, I want QR in terms of theta. Do you notice I have that already? So if I'm considering this, what is this? Opposite. What is this? So I'm done with number 1. It didn't even take me 10 seconds. Tan, opposite and adjacent. Tan theta is PQ over what? QR. What am I looking for? QR is PQ over tan theta. And what is PQ? X. We are done with the first question. Number 2. That didn't take us time. So katoa. You see, once you draw it out, it becomes easy. Show that QS is that. And I know this is where a lot of us, where's QS? Which triangle should we use? Do I know SQ? Nope. Okay, where's QS? I see that QS is in triangle 2. All right. Oh, wait, what do I know? I know QR, right? I told you, write the information. Look at triangle 4. Let me draw triangle 4 out. I see something very beautiful. Look at triangle 4. If you check triangle 4, we have something like this. I have R, white quickly. I have R, I have Q, and I have S. 120 degrees. I have X. And I have QR. What is QR? X over tan theta. What are we looking for? Let's see. Let's observe. I have what? And that angle is included. What is that? Cosine rule. I've been craving for cosine rule. All right. How do I use cosine rule, guys? This is small r, this is small q, and this is small s. I'm looking for r. You just need to follow the formula. If you remember the formula, it says a squared equals to what? B squared plus c squared minus 2bc cos a. Once I say a, it's the other two sides. I'm looking for r squared. I need the other two sides. Q squared plus s squared minus 2bc minus 2qs cos a. The angle there is there. What's the angle? I'm using r, so I should be dealing with cos r. Let's see. I hope we get an answer. Come, let's work together before you write. What is q? Small q. X squared. What is s? Small s? X over. Can I do this? Because it's squared. Minus 2. What is that? X. X over tan theta. Cos. What is cos r? 120 degrees. Beautiful. What will this give us? Please, algebra. Can I move to the next page? I need to do this carefully. Sorry, I know I'll rewrite it with you. Q squared plus s squared. I'll rewrite it so that we can quickly get this done. I'm taking just 2 minutes extra. This is what? X squared. X over tan theta. Let me do it like this. 2x. X over tan theta. Cos what? 120. Now let's simplify this together. What is r, by the way? R is qs squared. That's what we are looking for. Okay. Algebra. X squared tan squared theta, x times x squared. Now what is cos 120? Before you do cos 120, please change it into small angles. That is what? Negative cos 60. Reduce. There's a mark for that. All right. What do we have? X squared plus x squared over tan squared theta minus, this is now plus, what is tan cos 60? That's half. Okay, take it step by step. X squared. The way you write also matters. Look at these two and that two, they will cancel out. That two and that two would cancel out. Check here. Interesting. What's common? What's common? X squared is common. Let's pull it out. What are we going to have? 1 plus 1 over tan squared theta plus 1 over. Let's find the square root of both sides. Oh, this, I hope we are getting the answer. What is the square root of x squared? But now I can't find the square root of the other one, so I'm going to leave it like that. And because there's a plus there, is that what they want us to get? It looks like it. 1 second. Ta-da! 1 over tan squared, 1 over tan plus 1. Done. Guys, I hope it makes sense. Cosine rule. Side, angle, side. And that is it for the night. Good night, everybody. Thanks for joining us, for those that joined us for the first time. If you need more of this session, 0817442103, send us a message and we will give you all the information you need. And to our regulars, I hope you know where to find this, right? This would be added onto our list and you can go through over. We still have quite a lot of questions, so we're going to do this next week and finish up. Look, I've got that. Oh, I'm actually done. I wanted to just revise trig graphs. Oh, I was actually done. Oh, all right. So we'll just answer these trig graphs next week, and then we jump into stats. Beautiful. And I'll add a few more questions. I wanted to just revise a few of trig graphs. But that's it, everybody, and have a lovely, lovely evening. Ooh, we pushed today, hey? Beautiful. Beautiful.